So in this problem, we're told that a bullet of mass little m and initial speed v0 collides with a block of mass big M and sticks in it. The mass big M is attached to a rope of length L, which is held at a motionless pivot point, and the two combined masses swing up to an angle theta along that string. So what we're going to do is first we're going to find the initial velocity of the bullet block system by conserving momentum from the bullet initially. So this gives us m v0 is equal to m plus big M v final, which tells us that the final speed is equal to m over m plus big M times v0. Now what we're going to do is we're going to conserve energy after the collision. So once the bullet has stuck in the block, the two have some initial kinetic energy, and that mechanical energy is going to be conserved, but it's all going to be converted into gravitational potential energy at this height, h. So the initial energy is 1 over 2 times little m plus big M for the combined mass times v final here, which is m over m plus big M v0 squared. Now the final energy is going to be just little m plus big M times g times h. So when we multiply all of this together, we get 1 over 2 times m squared v0 squared over little m plus big M is equal to little m plus big M times g, and then h is actually just going to be L minus L cosine theta, because it's the difference between this length beneath this wall point up here and this height there. So it's going to be L minus L cosine theta. We can then divide everything out. We can divide out a factor of L from this, and we're going to get that 1 minus cosine theta is equal to 1 over 2gl times m v0 over m plus big M squared. So now we can move this around. We get cosine theta is equal to 1 minus this term right here, 1 over 2gl m v0 over m plus big M squared. And so now all we have to do is find theta is equal to the arc cosine of 1 minus 1 over 2gl times m v0 over little m plus big M squared. And so that gives us the final angle theta that the block bullet system swings up to. Now for part B, we're asked what portion of the initial kinetic energy of the bullet is lost in this collision. So we know that the energy that the block bullet system has after the collision is 1 over 2 times m squared v0 squared over little m plus big M. And this can be written in a slightly different way. If you pull out a 1 over 2 little m v0 squared term, and then you're left over with little m over little m plus big M. Now we know that the initial kinetic energy of the bullet is just this term right here. And so the amount that's lost is just big M over little m plus big M. And so this is the fraction of the initial kinetic energy that's lost to heat when the bullet lodges in the